Question 24. We've been given a diagram that involves some vectors, some of which we've been given in the diagram that we can see from the question, like little a, little c, and 2c, all representing the following vectors that I've shown on the screen. We've also got this point P dividing the line A to B in the ratio of 3 to 1, which I'm just going to add there for now. We've been told that Q lies on the point AC such that OQP is a straight line, so I can add that straight line in there based on what's in blue. And we're being asked to find the ratio of AQ to QC, which involves this line here. Now, when you're being asked to find a ratio, when you're being asked to find whether or not this is 3 to 1 or whether or not this is 3 to 4, so on and so forth, you're going to have an unknown involved in that ratio. And more often than not, it's easier to express it as a fraction. So like the first part here, the A to Q part, I'm going to use a letter K that's going to refer to the fraction of the whole line. So the fraction of A to C, I'm going to label as K. So for example, if K was a half, that part would be half of all of the pink line. If K was 2/5, then K here will be 2/5 of the whole line. We don't know what it is yet. We're trying to figure it out, so I give it a letter, but just to establish that it is a fraction of AC. The statement in blue, which tells us that we have this straight line, OQP, is a similar situation where we don't know what this ratio of O to Q to P is. So we do exactly the same thing where we introduce another variable. L, I'm going to use to refer to the fraction of the whole line there, the whole vector going from O to P. Now, when I say A to C and O to P here, it wouldn't have mattered if we did them the other way around. The fact of the matter is that you have a line that is of interest to the question, and you don't know what the ratio is, so we have to introduce an unknown. So this K and this L, we don't actually need the other part of this, like whatever fraction K is, this part will be 1 minus K, and whatever fraction L is, this part will be 1 minus L. We don't actually need those for this question, but it is important even just to be aware that you have alternate ways of being able to do this question. Now, Q is a point of great interest because of the fact that it lies directly on both of these lines. So we're going to be wanting to do some vectors involving Q. And the key to these ones where you don't know the ratio is find any vector from one point to another that involves the pink and blue line for one of them or the pink and blue line for the other. Now, what do I mean by that? Well, I pick any point on this diagram. Let's start with O. If I can go from O to, for example, Q, by using the blue line in some shape, way, or form in one way, and the K, the pink part, in one shape, way, or form in the other way, I will be able to answer this question. So for example, for O to Q, if I go from O to Q directly, that's going to involve the blue part there. If I go from O to Q via capital A here, I'm going to involve the pink bit there. If I go from O to Q this way, I would involve the pink bit here. If I wanted to go from O to A, I could go along to Q and up, which would involve both blue and pink, so both are covered in the same one. And then I could go from O to A just directly like so. You basically pick two different ways of going from one point to another that involve either separately or together the pink and blue parts that you see, and you're going to be able to create what will eventually be simultaneous equations. So with Q being a very useful point that involves both of them, it makes sense to me that having it as a point for this purpose makes a lot of sense. And O happens to just be a nice one to start with, so why not make it from O to Q? But like I said before, you can pick any 2 points in the entirety of the diagram, and as long as you have two different journeys, one of which has to involve, between the two of them, they have to involve the blue and the pink either separately or together, you'll have all the pieces that you need here. So I'm going to describe O to Q in two different ways. O to Q, first of all, I'm going to go directly, which I'm going to highlight here in yellow. And O to Q, I'm going to go indirectly via A, which I'm going to highlight here in green. And I'm going to use the information that's given here. So we have O to Q, which by the yellow way is just going to give me O to Q. But we obviously need something to work with this L, and the whole point of establishing this L is that it was a fraction of the whole of the blue line, which is O to P. So what we end up with here is L times whatever vector O to P is. That's our first step. We then look at what O to P is and try and describe it in terms of information that's been given. So to go from O to P, we have up to A, and then this 3 along to get to P. So our next line here, and you can do this separately if you want, or you can kind of keep it all together like what I'm doing here. O to P will involve the vector A, plus it's going to involve 3/4 of A to B. And A to B is 2C. So what I end up with next, I still have this L on the outside, or this L multiplying that I'll deal with in a moment. But here I've got an A plus 3/4 of 2C. My next line then is going to become 1.5C. You can write this as a fraction as well if you want. I'm just going to write it as a decimal because it's a nice fraction, or it's a nice decimal even. So O to Q can be described in the following way. And then if I break out that fraction, I'm going to end up with LA plus 1.5 LC. And that's my first way of describing going from O to Q. My second way of describing going from O to Q is going to start off by going from O to A, and is then going to go from A to Q. My O to A is just little a. My A to Q is going to be K is the fraction, remember, of the whole thing, so the fraction of AC. So I will have A plus K times whatever A to C is. So that sets up the following there. I don't know what A to C is yet, so I'm going to have to figure out what that is, just like before when I had to figure out what A to B is. So you've got lots and lots of pieces to this. You can, at the beginning, start to figure out things like A to B and A to P and A to C and stuff like that, but you'll never really know exactly what you'll need until you're in the moment. So it doesn't really matter what order you do this in. So A to C, how do I go from A to C? Well, with the information that I have, starting at capital A here and getting to capital C, I'm going to go this way first, which is negative A, and then this, which is plus C. So negative A plus C is the vector capital A to capital C. And then I'm going to simplify this by breaking it out. So I will have A minus KA, and then I'll have a plus KC. And that's going to give me the following. So I picked a way to go from O to Q, which was the yellow method here. I have then tried to figure out what it was by first of all using this as a fraction of the whole thing. And then of course that whole thing I needed to figure out, which is what I've done in the brackets here. And fully simplified, I end up with this. I've then chose to go from O to Q a different way, the green way, which was first of all going from O to A up here, which is just A, so that's this part there. And then for this last part, I've got K as a fraction of the whole thing, which I've done here, and then fully simplified it like you see here. Now, these look different, but they have to represent the same vector because you started from O and you ended up with Q. You've just gone different ways and you've just got different combinations of variables in it. So when you're dealing with two different vectors and then trying to figure out how they're the same as each other, you look at the individual parts themselves, which are the A's, and there'll be a reason why I highlight that in a minute, and the C's. The A parts and the C parts must be equal. So when I look at the C parts, it's easier to do this. I have a 1.5 L that's stuck to the C there, and I have a K that's stuck to the C there, which means 1.5 L and K must be equal. A little bit trickier with the other one because here there are two A terms, But what I can do is I can take a out as a common factor, leaving me with a 1 minus k. And it's this 1 minus k that we're then going to make equal to L, which is the multiple of the a in the other equation, the other vector. So from that we get L equals 1 minus k. What we've created now are two pairs of simultaneous equations which we can then solve to figure out L and K. And once we've figured out what L and K are, we'll be able to actually answer our original question, because our original question, the ratio of a line, is going to involve one of these letters. So, solving these simultaneously, if we know that K is 1.5 L, then I can just plug that in here and solve the equation as it's seen. So L equals 1, take away this, add 1.5 L to both sides, and we'll end up with this. Divide both sides by 1.5, and I'm going to get this, which I could also write as 2/5 as a fraction. Then plugging it back into here, we're going to figure out what k is. If I have 1.5 times 0.4, I'm going to end up with 0.6, which is k, and as a fraction, that's 3/5. So we figured out what L is, we figured out what k is, now we need to see which one we actually want. So the question itself was interested in the pink line, which means that this k here is what we're looking for. 3/5 was the fraction for that, which makes 1 minus k, the other part of the line, 2/5. So our ratio here, this a to q to c, as it stands, is 3/5 to 2/5. But of course we wouldn't leave a ratio like that with fractions in it. If we multiply both sides by 5, what we get as our final answer here is a ratio of 3 to 2. Done.